Hello there, my name is Mankaran Singhal and I'm a student of BIT121 Network Communication Concepts, and today I'm here to give up a video presentation for the assignment. So to start with, the first part of the assignment was to explain a concept of networking, the technical terminology, and for that part I have chosen to explain bipolar AMI. In communication, bipolar encoding is a type of return to zero line code where two values are used so that the three values are plus, minus, and the zero. Such a signal is also called a DO binary signal. Standard bipolar encodings are designed to be DC balanced, spending an equal amount of time in the plus and the minus stage. One kind of bipolar encoding is a paired disparity code, of which the simplest example is the alternate mark inversion. In this code, binary zero is encoded as 0 volts, as in a unipolar encoding where binary 1 is encoded alternative as a plus voltage and also a negative voltage. Also a negative voltage, yeah. The name arose because in the concept or in the context of the T carrier, a binary 1 is referred to as a mark where where while a binary 0 is called a space. The use of bipolar code prevents a significant buildup of a DC, as the positive and negative pulses average to 0 volts. Little or I can say non-DC component is considered an advantage because the cables may then be used for a longer distance and to carry power for an intermediate equipment such as line repeaters. The DC component can be easily and cheaply removed from the signal when it reaches a decoding circuitry. So the next part of the assignment was to give me a sec. What was to explain a multiplexing technique with example and a typical application. So to start with, what is multiplexing? In telecommunication and computer networks, multiplexing is a method by which multiple analog or digital signals are combined into one signal over a shared medium. The aim is to share a scarce resource, for example, a printer. A device that performs the multiplexing is called a multiplexer. For this, I have chosen to explain the frequency division multiplexing. Frequency division multiplexing is inherently an analog technology. Yep. So it's an analog technology rather being a digital one. Uh, so I'm going to abbreviate frequency division multiplexing as FDM. FDM is achieved by combining several signals into one medium by sending signals into several distance frequency ranges over a single medium. In FDM, the signals are electrical signals. So the main thing in FDM is that they are electrical signals, not any other form of signals. One of the most common application for FDM is traditional radio and television broadcasting from the terrestrial, mobile or satellite stations, or a cable television. So all those things which receive broadcasting from a terrestrial medium uh, are the examples of FDM. Uh, only one cable uh, Only one cable reaches customers' residential area, but the service provider can send multiple television channels or signals simultaneously over that cable to all subscribers without interference. Receivers must tune to appropriate frequency to assess the desired signals. For example, there are frequencies on the radio. There are different frequencies ranging from maybe 87 on some radios to 108. we can access, there are different channels, different frequencies. So there would be one channel on 90.5, then there might be another channel on 90.6. So for the receiver, but it's the same thing, they are transmitted from one base, one cable, or one signal, but we have to uh, reach an appropriate frequency to uh, assess the desired signal. So the next part of the assignment was to explain our following concept with an example and a typical application. So for this, I have chosen to differentiate between analog and digital communication. To start with, what is an analog signal? Analog communication. An analog communication is a form of communication in which an analog in a continuous wave that changes over a time of a period, whereas a whereas a digital signal is a discrete. We need to focus on the signal. Like analog has a continuous wave, and digital has a discrete wave that carries information to binary for RMM.